everyone. My name is Dana Golden. Today I'm going to give an introduction to integrated assessment models as a continuation of our look into environmental macroeconomics. So integrated assessment models are tools that integrate knowledge from multiple disciplines to analyze complex systems. Economics on its own can't handle climate change because climate change has a lot of interplay with broader systems, and you need to think about how the science plays into it to inform models of climate change and help us think about policy decisions on climate change. So IAMs help us evaluate costs and benefits of climate policies and estimate the social cost of carbon, thinking about trade-offs between economic growth and environment. IIMs traditionally have an economic module that looks at economic growth, energy use, and investment, and captures the feedback between climate impact and economic productivity. Then they have a climate module where they look at greenhouse gas emissions, atmospheric concentrations, and simulate temperature increases and climate impacts. Then they have a damage module where they estimate economic and social costs of climate impacts. They look at the costs of extreme weather, sea level rise, and biodiversity loss. Finally, they have a policy module where they look at mitigation, adaptation, and policies. So the reason why these things are so important and cool is because it helps you see, one, what goes into the climate change and economics from a broader view, but two, also what there can be in terms of feedback loops. I talked about earlier how neoclassical economics doesn't do a great job of dealing with feedback loops, and how new work in environmental economics tries to work on this front. Integrated assessment models are where that's really happening, is where you're thinking about how climate change branches out and affects the economy, and how the economy can affect climate policy. So types of integrated assessment models, you have policy optimization models like the DICE model, which we'll talk about in a moment, which maximizes social welfare by balancing mitigation costs and climate damages. You have simulation models like the regional integrated climate economy model, which simulates interactions across regions with heterogeneous policy. And you have the energy economy environment models like the global change assessment model, which I believe we'll also talk about today, which focuses on energy systems and technology pathways for emissions reduction. So mostly applications of integrated assessment models. You have a social cost of carbon, which is the monetary value of damage caused by emitting 1 additional ton of CO2. Integrated assessment models allow us to estimate carbon pricing and guide that policy. They also allow us to evaluate the economic and environmental impacts of policies like carbon taxes, cap and trade systems, and renewable subsidies. And they help us to assess both how to reach net zero emissions and how to limit warming. System strengths and limitations of these models. They help integrate complex systems into a single framework. They provide quantitative insights for policy decisions. And they highlight trade-offs between economic growth and climate goals. However, they make a lot of simplifying assumptions that overlook system complexities. I think this is really the biggest problem that these have, is that often they dramatically overestimate how bad certain levels of climate change will be. And, they have difficulty thinking about tipping points and technology breakthroughs in capturing uncertainties. It's very difficult to think about these kinds of uncertainties because it's, in economics, we're very good statisticians and we're very good thinking about in-sample errors and stuff. But this is really about out-of-sample errors. And then, there's a lot of ethical debates on discount rates, internal equity. These are definitely things we need work on, and I would accept if you wanted to do it for the project of this class, I would accept even like a lit review looking at integrated assessment models and where you think you might be able long-term to make progress. So the DICE model is a pretty standard workhorse model developed by Wildham Norhaus who now has won a Nobel Prize in macroeconomics to integrate climate and economic systems. It combines a macroeconomic growth model with a climate module, and the goal is to optimize economic output while mitigating climate damages. It captures trade-offs between economic growth and emissions reductions and consumption today and long-term sustainability. It was really the first major framework for thinking about the total cost of carbon. Today, we probably think that underestimated the cost of climate change, but was a first try. So the economic module, you have output as a function of technology, capital, and labor. You have a climate module where you have emissions, you have a mitigation rate, and then the more you produce, the more you emit, but also you have the ability to mitigate it, and that is endogenous. You can think about how to prevent more pollution and choose to engage in technologies that prevent more pollution. This is very similar, by the way, to the green solar model, and I think you can see how this builds out of the green solar model. So the damage module, which is how you assess the impacts of economic actions on the environment. You have a fraction of output lost due to damages that is this non-parametric function of the emissions. I said it is a parametric function. Yeah, I guess this counts as a parametric function. It's a function of the emissions. I shouldn't say non-parametric. They did a quadratic term. They didn't use a B-spline. So key trade-offs in the DICE model: economic growth versus emissions reduction. Investing in emission mitigation reduction reduces consumption today, but lowers future damages. And then consumption versus mitigation development, balancing short-term welfare with long-term climate stability. So you have these, when you do a macro model, as you learned in 305, I believe it is, in macro, you have these trade-offs, and here the trade-offs directly include how to think about mitigation investment and how to think about emissions reduction. They maximize utility depending on consumption, with choices of also trying to reduce emissions and mitigate, invest in mitigation technologies with a discount rate of rho. Symbolic implications, this helps provide a optimal carbon price. It helps provide the argument for investment in green technology, and the biggest argument for investing in green technology is that it lowers mitigation costs over time. It helps demonstrate there's a global externality of climate change, and it provides an argument both for global coordination and for how we should go about global coordination. And then it allows us to think about how to balance welfare cost generations and over long periods. So future directions, and like I said, you are the future. You're watching this because you're interested in making the environment better. I would hope that you didn't take environmental economics thinking, actually, I see all externality minimization problems as externality maximization problems. I want to maximize the amount of carbon in the atmosphere. Let's destroy this. I think you're here because you care. And so future directions: improve representation of uncertainties and tipping points, integrate climate equity and justice in IM frameworks, think about distributional impacts of climate change and climate policy, and enhance regional and sectoral granularity. And obviously, there are a lot of people who are working on coupling IMs with machine learning. This is particularly big because there's a lot of deep learning that's very useful for this sort of dynamic modeling. There's a lot of simulation that makes it very difficult. They also want to incorporate more environmental data and real-time data for the dynamic modeling. Let me know if you want to do this for a project. I think it's a very cool area of research, and I'd love to hear anyone's thoughts about it. And I hope you have a great day. Thank you.